Solving systems of equations with substitution. When solving with substitution, the first thing you want to do is make sure one of your variables is isolated in one of your equations. In this case, the y is isolated, so we're going to take the negative 2x minus 7 and plug it into our other equation. So now we are left with 2x minus, use parentheses and plug in negative 2x minus 7, close your parentheses, and finish the rest of your equation. Then you simplify. So we're going to distribute the negative. 2x plus 2x plus 7 equals negative 1. Combine like terms. 4x plus 7 equals negative 1. Subtract 7 from both sides. 4x equals negative 8. Divide both sides by 4. And x equals negative 2. So now we found the solution for one of the variables. We need to take that solution, plug it back into the equation, so we can figure out what the other variable equals. It does not matter which equation you plug your answer into. In this case, since the y is by itself and that's what I'm looking for, I'm going to plug it back into the second equation. So I have y equals negative 2 times the x value you just found, negative 2, minus 7. Then you simplify again. Negative 2 times 2 is positive 4, minus 7. 4 minus 7 tells me y equals negative 3. Then you write your answer as an ordered pair. Negative 2, comma 3. Negative 3. When you are all done, please make sure to go back and plug in your answer into both equations to make sure it actually does work and you didn't solve anything incorrectly. So if I look at my first one, 2 times the x value I just found, negative 2, minus the y value I just found, negative 3, equals negative 1. 2 times negative 2 is negative 4, minus a negative is plus 3, equals negative 1. Negative 4 plus 3 is negative 1, which equals negative 1. So it works in the first equation. In the second equation, same thing. So it's the y value we just found, negative 3, equals negative 2 times the x value, negative 2, minus 7. Negative 3 equals negative 2 times negative 2 is positive 4, minus 7. Positive 4 minus 7 is negative 3. So it works in this equation as well. And our answer is negative 2, negative 3. Now, if there's an instance where the variable is not isolated, you need to go through and solve. So I'm going to take this first equation, 2x minus 6y equals 14, and solve for x. So I add 6y to both sides. 2x equals 6y plus 14, and divide everything by 2. X equals 3y plus 7. Now again, it does not matter which equation you use, which variable you solve for. You just need to make sure you look ahead and try to figure out which variable is the easiest. So for example, if I were to solve in the second one, I would probably try to get the x by itself rather than the y, otherwise I'll be dealing with fractions. Once I get this x value all by itself, I'm going to take the 3y plus 7 and plug it in to my other equation. So in this case, I have 3y minus the x value you just solved for, 3y plus 7 equals negative 7. Again, solve for y. So we distribute 3y minus 3y minus 7 equals negative 7. Combine like terms. 3y minus 3y is 0. 0 minus 7 is negative 7, and that equals negative 7. So this is an instance where our variables cancel out and we are left with a true statement. When that happens, your solution is going to be all points on the line. Because what happened here was you have the exact same line. It just looks a little bit different because of the numbers, because of the format. But if you were to graph this, you would only see one line in your graphing calculator. And that would be a way to also check this answer. Plug both into your calculator, make sure you solve for y. When you graph it, you will get the same line. When you check your table, you will have the same answer in your y1 and y2 column. So let's try another one where we need to solve for y, or solve for a variable. So in this case, the first one looks like it's the easier problem to get a variable by itself. So y minus 3x equals 2. All I need to do is add 3x to both sides. My y is isolated, and that equals 3x plus 2. Take the 3x plus 2 and plug it into your second equation. So now we have 3 times what your new y value is, 3x plus 2. Then continue writing the rest of the equation. Plus 21 equals 9x. Distribute the 3. So 9x plus 6 plus 21 equals 9x. Combine like terms. 9x plus 27 equals 9x. Subtract 9x from both sides, and 27 equals 0. So this is another case where all of your variables cancel out, but you're left with a statement that doesn't make any sense. 27 cannot equal 0. When this happens, essentially what you have are two parallel lines. Since you have two parallel lines, they have no intersection points, so they share no numbers in common, which means your answer will be no solution. Again, to check your work, solve for y in both of your equations, plug them into your calculator, and you will have two parallel lines.